Hello.
Hello.
How are you, Abe?
Good, good. How are you, Ricardo?
Doing well.
Yeah,
Sunny day.
we've been here setting this thing for a while to start to try to record a small session coding. Let me see, where do I have these? Some old generative artworks. So we're recreating this in OpenRNDR.
From the 70s, isn't it?
Yeah, this is from 78. This is 76, 77.
Hmm.
And so we can just get started. I have the IDE here and not yet any project, so I'm just gonna clone the template, which I've done many times. That's why I have here the URL, and I just put it in the temp folder. So because
Hmm.
I'm not gonna keep it probably, or I'll move the code somewhere before
Of course.
deleting. So yeah, so this is the what we see when we first. The first thing we see after cloning the template. And in the source main Kotlin folder, we can see the template program, and which is this. It's still indexing, which happens first when you open. And I don't know if it's first when you clone the project or sometimes when you open the project. I don't know. But yeah, we have to wait for a second, and then we can run the program.
It is a mystery.
I think it's also yeah, because I just cloned this from the repo. Like in my other folder, it would be just indexed. But yeah, okay.
Probably.
So now we can run the template program KT, and we should see this. What is it? The adjustment chart and some text moving. If we are lucky.
It has been there since ever, I think.
Yeah. So is it visible on your side?
It is, it is.
Yeah. Cool. Great. So so this is a basic program. Maybe I can increase the font size and we can simplify just to start with something very minimal. Uh, Maybe just I'll put a circle on the screen to see if it still works. On the top left corner and this radius. And I have a shortcut to organize the imports, so they are automatically removed.
Oh, that's cool.
Uh, yeah. And then I run it again, and we should have the circle there. Yeah, it's there. Cool. So what are we gonna? We can try this thing first.
Sounds good.
Yeah, so we could name the program, the file, like this. And we could use the grid feature. And the grid feature is part of an ORX, which I don't remember which one. ORX shapes, maybe? There's an extension for that is not part of the core. And I think that makes anything that's based on a grid very easy. So I'm gonna rename this file, and I'm gonna call it like that. And then to add an ORX, we have to go to the build Gradle.kts and what is it? Shape. Maybe it is there. Shapes. I think it's shapes. Let's try if it
Could be.
works. Can we make a grid? Val G is it's part of the rectangle. So drawer bounds rectangle. No, it's not there.
Bounce is already a rectangle.
Yeah. Sorry, it's not rectangle but grid. Distraction. So this would make a grid of 20 columns and 20 rows. And then we can do something with it.
Start in the top left corner, no?
Yeah, left top. It has more options to add some padding and stuff. Like we can see margins and
Hmm.
gutters. We can first start like this. One thing I always do is to flatten it, because otherwise we get oh no, not flat map, flatten. Otherwise we get a list of lists, and I just want to have a list of rectangles, which makes it very easy to draw them. Then we can draw rectangles, it's nice that in OpenRNDR there's all these plural methods that take lists of objects. Instead of drawing one rectangle, you draw a list of them. I should give it a better name, I guess. So, what should we call this?
Grid.
Where's the key? Grid. Okay. So this, I hope, draws something. I don't know. Depending on the settings on or what they click on the fill and the stroke.
Yeah, exactly.
Yeah. But yeah, there is something there.
Close by.
Yeah. It's nice. It's one line of code.
I guess something to talk about is the aspect ratio, right?
Yeah. I'm gonna make it square because
Yeah, it
the
would be easier.
original is square, like we can see here.
Exactly.
And this looks more or less like 10 columns and rows, something like that. And we can add some of the other variables here, the other arguments, which were, I think it's the padding and the space between them. Well, but in in our example, we don't have any space between the cells, so we can leave it at 0. So if I run it again, now we have some padding and 10 columns and rows. And how would you make it white, the background?
So you would use drawer.clear
Okay.
before the rectangles.
Clear. And I really like this autocomplete that you can just start like on WH and it knows that it's white.
Yes, it's very handy.
Yeah. So now we have a white background. And we can see that some of those lines are, well, repeated. So
I think in the original there's also different stroke widths.
Okay, let's look at it.
It doesn't seem to be like what we have now, but
yeah, it looks like kind of like a photocopy or something. I think it's like I don't know how much is printing, or did they use actually a pen to do this? A pen plotter maybe? Who knows? But yeah, we can play with the stroke. Yeah.
Could be because in the lower left corner you see that one of the lines actually goes a bit further.
Yeah. Yeah. Yeah, maybe maybe they cropped the thing. Okay. So instead of having full rectangles, maybe we want to take only one of the sides. How could we do that? I think we could convert, so we could map the grid into something else. So we could say lines is grid and map. So mapping, what it does is we're going to convert the items of the grid, which are rectangles. If I leave the mouse here, you can see there is a list of rectangles. And I would want here to output line segments, maybe.
Yes, so, I would. Yeah, you can make it a contour as well.
Yeah.
Several options there. You can also just stay within the rectangle, and you can sample the positions like via UVs, right? Imaginary UVs, and just get the corners, right? You would just give it a vector from 0 to 1. And you could also build like that. But I think the segments is the easiest one, because then we can, with random, we can basically only get the elements that we want.
So to get the segments, I guess we should get the contour first, or no?
Yes.
Contour. And the contour has what?
Segments.
Segments. Let me see. Where's my segments? It's a list. Cool. And I think there's even isn't there like a random method?
Is it from a Kotlin or from OpenRNDR, this method?
I think it's from Kotlin. So this would make it super easy, because it's just taking one of the segments of the rectangle. And so now lines is a list of segments. So instead of drawing the rectangles, we could draw what is it? Line segments, yeah, and lines. And
I think it's segments only
to segments.
because it's a there
Ah,
is a line segment
yeah,
and a
yeah, yeah,
segment.
yeah. Right. Cool. So how close did we get? Very close. Yeah,
Looking good.
yeah. Now, just for fun, like if we imagine we wanted to remove a few of these, we could. How could we filter? Um, we have lines, so instead of drawing them all, we could. Can we do something here? Like, yeah, maybe filter. Yeah, and then.
I think some control over how many segments get removed could also be
Uh huh.
interesting.
Uh huh.
We could so we know that the rectangle has 4 segments, right? So we
Yeah.
could use the random from the random singleton from ORX noise, which has
Uh
a
huh.
method called pick.
Okay.
So if you write random with capital starting with a capital R,
Where should I write that?
you can wrap around, so remove the it dot contour segments dot random if you remove the random part,
Uh huh.
and then then wrap it with a parenthesis and then start writing before it. Yes, now you can write before random dot pick,
Pick.
and this will pick one element only.
Okay.
But
Uh
you
huh.
can specify with a second argument. I think you have to do named argument.
Well, first I have to import, so I hit here Alt Enter, and I have to choose one of these, which is the noise, the
Exactly. Yes.
OpenRNDR noise.
Comes with ORX. Yes, you can do. Um, if you right now count equals, because the second argument can also be used for which segments you don't want, or which which
Mm-hmm.
segments you don't want to pick. So now you just
Okay.
specify a count. You can also use a random again, random number if you
Mm-hmm.
want. That would no.
Let's see which.
So till 4. In this
Uh huh.
case, yes, till
Ah,
4.
okay. I see. Is which one of the four?
Yeah. So
Uh huh.
in the elements that you have, how many do you want
Mm-hmm.
it to pick, and then you get a list of those elements.
Okay. So I should use a random number between 1 and 4.
Yeah, so you can do 3, and then we always have 3 segments,
Uh
just to
huh.
try it out, for example, to see the result.
It probably will look very much like a grid because they will. Oh, what did I miss? Ah, the
Yes.
lines. What kind of object do we have now? It's a list of mutable list of segments. So I should maybe flatten it.
Yes, exactly. Yes. You're right. Maybe we should only choose 2, perhaps.
Yeah, well, let's see still to confirm the theory.
Mm.
Yeah, in most cases, yeah, if you get 3 on one side and then the neighbor also has that one, then it looks like a square. But it's
Mm.
cool. It's also nice to have some missing unlucky squares. And if we have 2, then yeah, there's gonna be more white space. Yeah. And if we wanted to randomize it, for example.
Yeah, you can use a dot int 0, which you can also use the method int
Yeah.
0, yeah,
In 0.
because then it starts just an easier way, and then
So
maximum 2 or 3.
mm-hmm. Let's see. So now some squares will have no edges because they get 0.
Yeah, exactly. So it becomes more sparse because the
Yeah.
number is really low.
Mm-hmm. So we can just to take a look again. What are we doing here? We have the grid, and the grid is contains all the possible rectangles in this space, and then we are gonna map. So we're gonna convert that collection that has all of them into a different collection, and there we are picking some of the segments of each rectangle. And it can be between 0 and 2 in this case. And then we flatten it, so it's basically like having a lot of sticks that we dropped on the floor or something. And yeah, then we can draw them.
Exactly.
What else could we do?
Do we want to approach the stroke width, perhaps?
Right.
Having a different stroke width throughout.
First, we could just show like what does it do, or even if it's very basic, that we could draw a stroke weight. It's a double number, so now I guess they are all much thicker. Yeah. And we wanted to maybe randomize it. How could we set a different one for each?
In this case, I would loop over the lines.
Okay. So we could make a collection. We could make pairs maybe of.
Do you want to have the adjacent ones to be?
Just to have each line to have its persistent stroke weight.
So you can also make use of going back to the random singleton. The advantage of it is that it's seeded, so it should return the same result, right?
That's probably the easiest, yeah.
And if I'm not mistaken, you can do there's also a random.isolated. So instead of doing that, there's already a method there. You do isolated, and then it works kind of like the. It has the same way of functioning, like the push and pop when when we do drawer. I think it's drawer.isolate if I'm. Yeah. So it has the same mechanics. So this should always return the same.
So then we shouldn't draw them all at once, but.
Exactly.
Like,
yes.
Yeah. Like lines for each, and then we can do drawer segment, and we draw it, which is the current segment. I don't like leaving commented out code. Some people like to leave it in case they want it for later. So now we're drawing them all. So now we should set a unique stroke weight for each.
Exactly.
Random double. Or we could use even a few integers, like integer between 1 and 5, and then we convert it to double.
So now, because you're inside of this, your context, this is the random, so you don't need to write it again.
Right, we can see that it's grayed out. That's why,
exactly.
Yeah, it's optional. But I think it's in this case it might be more readable because this looks slightly strange, like looks like int 1,5. But it works. So let's see them with random width, which is cool.
Yes, that's some variety.
If we had more time, then we could try to simulate this photocopy effect and have defective lines. But we can leave this for another video.
Yeah, I think so.
Yeah. But it's cool. So I think
good job.
We kind of achieved making this more or less. It's rather simple with these higher level functions that OpenRNDR offers, like grid and others. I don't know about you. I find that OpenRNDR has like both like higher level and lower level features.
It has a lot of ground to explore, for sure.
Yeah. Like sometimes you can do like very low level like compute shaders, but then you can do things like intersections between shapes and stuff like this that you don't have to figure out yourself.
Yes, agreed.
Cool. So I think we could end here this first experiment we've done. And we continue with the other Recode project designs in the next episode.
Let's do it.
Okay. Good to hear you. Take care.
You too. Bye-bye.
Bye.